let's take a look at what we do when we're solving equations that have variables on both sides. So the basic idea is that while other things could be happening, okay, we'll see an equation that has multiple variables happening, but those multiple variables are happening on opposite sides of the equal sign. So we can no longer just sort of circle our x, right? It's happening in two different places, right? The other important thing is they have to be on opposite sides of the equal sign for this to be the approach we are going to take. If the variables are not happening, right, here's my equal sign, there's one on the right and there's one on the left. If they're happening on the same side of the equal sign, then you need to go back and watch the video over multi-step equations. So when variables are happening on both sides of the equal sign, okay, we need to get those together by using the opposite sign. So the multi-step equations, when the variables are on the same side, we're going to get them together with the same sign. When the variables are on opposite sides of the equal sign, we're going to get them together with the opposite sign. Okay, so we have an x here and we have an x here to get together. They are on opposite sides of the equal sign. There isn't a rule that says you have to move one of them or the other. You can decide which one you want to move. Typically, my students prefer to move the smaller variable. This will help you avoid negatives, okay? So between 6 and 4, 4 is our smaller one. Okay, so just like we've been doing throughout our other videos, we're going to look in front of the number and we're going to decide if it's positive or negative. Because we don't see anything in front of this 4, we know that this is a positive 4. So we will do the opposite of a positive 4, which is a negative 4, right? Negative is the same as subtraction. So 4x minus 4x, those are just going to cancel out. And over here we'll have 6x minus 4x, which will give us a 2x. Everything else is going to come straight down. So my adding 4 will come down, my equal sign, and my positive 12, right? I don't need to write the positive. Nothing is assumed that it's positive. And then from this point, we just have a regular two-step equation. If you're unsure how to solve this, you should go back and watch the video over solving two-step equations, right? But we're undoing addition with subtraction. And then we will undo multiplication with division. And we will get an answer of x equals 4. Now, when we open the door for variables on both sides, some other unique things can happen. For example, let's say we have the equation 2x equals 8x plus 18. Okay, so again, we have variables happening on both sides of the equal sign. Okay, so we want to get them together with the opposite sign. They're on opposite sides, so we're going to get them together with the opposite sign. Now, if we follow that rule that we want to move whichever one is smaller, we're going to run into a dilemma because there's nothing left on this side of the equal sign. Okay, and while you can go the route, it would not be incorrect to say the opposite of a positive 2x is a negative 2x. You would have to make sure that when you bring this down, this actually becomes 0. Okay, and then you're left moving something back over there. So my suggestion is that when we have something that is the piece we want to move, but there's nothing else over there with it, even though this is smaller and it might make more sense, let's actually move the other one. Let's never empty a side. Okay, make it so a side never becomes completely empty. Okay, so instead, let's move this positive 8x with a negative 8x. Okay, 2x minus 8x gives us a negative 6x. Right, and now we don't have anything that we need to move back to fill in that side. We can just simply solve, undoing multiplication with division, and get x equals negative 3. Now, if you would have gone this route and if you did this correctly and made this a 0, you still could have subtracted and divided, and you would still get an answer of negative 3. Now, we can have more things happen with variables on both sides. So maybe we have 6 minus 4x equals 12 minus 3x. Okay, this is a bit of a tricky situation because my students will look at this and they'll see the variable here and they'll see the variable here, and they'll realize that they want to make the decision about moving the smaller variable. You have two choices, okay? One, when we are dealing with negatives, right? This is really negative 4x and negative 3x. We have to remember that negatives kind of seem backwards. So negative 4 is actually smaller than negative 3 because it's more negative. Okay, and so in fact, the smaller variable to move is here. Okay, so they're on opposite sides. We're going to use the opposite sign. When we combine these, be really careful because we really want to take a negative 3x plus 4x. So we'll have 6 equals 12 plus 1x. And then we can finish solving. Maybe we have something like 3 times 2x plus 4 equals 6x minus 5. Now, we've talked about this in the previous videos, but when we see parentheses, we often want to distribute to get that simplified so we don't have to deal with multiple things happening over there. So if we distribute this 3, we distribute through multiplication. That would give us a 6x plus 12 equals a 6x minus 5. And now we are able to do something with these two variables. Here, you cannot move that 2x because this 2x is stuck inside the parentheses. But once we've distributed and simplified, the parentheses have gone away and we can get these together. Now, if we decide what's smaller, 6x or 6x, we run into the dilemma that they're both the same. So it doesn't matter which one we move. Okay, but we have to make sure we understand that 6x minus 6x just goes away, right? It becomes 0. There's nothing to write there. And again, that same thing happens over here. So the only thing that we have left is 12 equals negative 5. Don't fill in an x. Don't try and add an x just because you don't see one. Okay, in fact, what's happening is our variable goes away and we have to decide if this statement here is true. Does 12 equal negative 5? Okay, we have to decide if that is a true statement or if that is a false statement. Okay, 12 equaling negative 5 is not true. That's a false statement. And that means that our answer is going to be no solution. That means there's no possible answer to this problem. If this were to be a true statement, maybe we solved and we got something that said 6 equals 6, right? That's true. 6 does equal 6. Then we would have an answer of all real solutions, or we could say infinite many solutions.